Alright, parametric differentiation. Let let x be some function of t and y be a function of t. Then dy by dx would be equal to dy by t multiplied by dt by dx. And d2y by dx squared would be um, the differential of dy by dx with respect to t multiplied by dt by dx. Example 33. It says the equation of a curve is defined by x is equal to 6t squared minus 5. So x is equal to 6t squared plus 5, and y is equal to t cubed plus 2t plus 1. We're to find the gradient of the tangent to the curve at t is equal to 1 and find the value of d2y by dx squared at t is equal to 1. Alright, let us find dx by dt. So dx by dt would be equal to 12t, be equal to 12t. 2 times 6 is 12. Reduce the power by 1 from 2 to 1. If you differentiate to 5, you're going to get 0. Now, y is equal to t cubed plus 2t plus 1. Now, dy by dt is equal to 3t squared plus 2. Alright, now dy by dx, which is the gradient of the tangent to the curve, is equal to dy by dt multiplied by dt by dx. In other words, dy by dx is equal to 3t squared plus 2 over 1 multiplied by the Southern reciprocal of dx by dt. So it's multiplied by 1 over 12t. So we can say dy by dx would be equal to 3t squared plus 2 over 12t. dy by dx is equal to 3t squared plus 2 over 12t. I believe we're asked to find the value of dy by dx when t is equal to 1. So to find the gradient of the tangent to the curve at t is equal to 1. So let's find that by saying when t is equal to 1, dy by dx is equal to 3 times 1 squared plus 2 over 12 times 1. Therefore, dy by dx would be equal to 3 plus 2 over 12 is equal to 5 over 12. So therefore, gradient of tangent to curve at t is equal to 1 is 5 over 12. We're also asked to find the value of d2y by dx squared at t is equal to 1. Now, d2y by dx squared would be equal to the first derivative, differentiate dy by dx by, with respect to t, so it's dy by dx. You differentiate that with respect to t, multiplied by dt by dx. All right, so let us start out by differentiating dy by dx with respect to t. So the differential of with respect to t of dy by dx. Now dy by dx, sorry, let's start out with dy by dx again. So let's start out with dy by dx. dy by dx is equal to 3t squared plus 2 over 12t. All right, this is a quotient. So we're going to apply quotient rule when we differentiate. If we apply quotient rule, d so the differential of dy by dx with respect to t, what we're going to do is it's equal to v, which is the bottom. So this is u over v. It's equal to v, which is the bottom. So that's 12t multiplied by the differential of u, which is 6t, minus u. Right, let's create a little bit more space. All right. We could probably remind persons of. Let's just remind ourselves a little. If y is equal to u over v, dy by dx would be equal to v du by dx minus u dv by dx all over v squared. So now the first differential of dy by dx with respect to t, since it's a quotient, we're applying quotient rule. So it would be v, which is 12t, that's at the bottom, multiplied by the differential of the top. When you differentiate 3t squared plus 2, you're going to get 6t minus u, which is 3t squared plus 2, multiplied by the differential of the bottom, which is 12. And this is all over the square of the bottom, which is 12t squared. So if we simplify, we're going to end up with, this is what? 72t squared minus, this looks like 36t squared minus 24 all over 144t squared. All right, so if we continue on the next page, we would have this would be equal to it'd be equal to 36t squared minus 24 all over 144t squared. 12 is common, so if I factor out 12 or divide both numerator and denominator by 12, I'm going to end up with 3t squared minus 2 over 12t squared. Then I'm going to say before we go there. Alright, so this would be now d2y by dx squared would be equal to dt of dy by dx multiplied by dt by dx. So this would be equal to 3t squared minus 2 over 12t squared multiply, if I'm not mistaken, alright, let's go back though. I think this is 1 over 12t squared again, but let's just go back to double check. Alright, dx by dt is 1 over 12t. So this is multiplied by 1 over 12t. So our final answer here, this would be 3t squared minus 2 over 144t cubed. And then now when x is equal to 1, d2y by dx squared. Alright, correction, this is when t is equal to 1. When t is equal to 1, when t is equal to 1, this would be equal to 3 times 1 squared minus 2 all over 144 times 1 cubed. So this would be equal to 3 minus 2 over 144. The final answer is 1 over 144. Next question. Example 34. Example 34 says the equation of a curve is defined by x is equal to sine 4t. So x is equal to sine 4t and y is equal to 2 cos 4t minus 1. Show that dy by dx is equal to minus 2 tan 4t. And find d2y by dx in terms of t. Alright, dx by dt, differentiate sine, you get cos, so this is 4 cos 4t. The 4 at the front is because you differentiate cos, sine you get cos, but then you have to multiply by the differential of the inside function. Y is equal to 2 cos 4t minus 1. Now dy by dt is equal to, now you differentiate cos, you're going to get minus sine. So this is 4 times minus 2 sine 4t. And if you differentiate the 4 at the front, you differentiate cos, and you have to also multiply by the differential of the inside function. When you differentiate minus 1, you're going to get 0. So dy by dt is equal to minus 8 sine 4t. Now dy by dx would be equal to dy by dt multiplied by dt by dx. So this would be equal to minus 8 sine 4t over 1 multiplied by the reciprocal of dx by dt, which is 1 over 4 cos 4t. So this is 1 over 4 cos 4t. Alright, so listen to this is 2. So the answer is minus 2 tan 4t equal to minus 2 tan 4t. So what we're asked to do, we were asked to show that, and it came out to be exactly that. We're asked to show that dy by dt is equal to minus 2 tan 4t. Now we're asked to find d2y by dx squared in terms of t. Alright, first of all, d2y by dx squared would be you differentiate the differential with respect to t of dy by dx multiplied by the reciprocal of dx by dt. So that's dt by dx. All right. So let us differentiate dy by dx. dy by dx we have so dy by dx is equal to minus 2 tan 4t. Now we're going to differentiate dy by dx with respect to t, and differentiate tan, you're going to get sec squared. Differentiate tan, you're going to get sec squared. So this is 4 times 4 times minus 2 sec square 4t. So this would be minus 8 sec square 4t. Now, therefore, d2y by dx squared would be equal to minus 8 sec square 4t multiplied by 1 over 4 cos 4t. All right. Again, 4 into 8 is 2. So this is equal to minus 2. And 1 over cos is sec. So this is going to be sec square 4t times sec 4t. So this is equal to minus 2 sec cube 4t. Equal to minus 2 sec cube 4t.